You're back for the follow-up episode. Why don't you introduce yourself?
I'm Chris Willis. I am the solutions engineer in the federal space. My last video I did, we talked about the DevSecOps pipeline that I created for one of my customers. And that really dealt with this larger conversation about transformation and transforming your security process, putting security at the heart of things, but not slowing things down, using automation, making sure you're using automation to speed things up rather than increasing complexity in how you're tackling security challenges.
I liked where we got with that conversation because there was there was two parts. There was a good kind of practical definition of DevSecOps, or just to put it another way, doing security and like container-driven like development and applications and things like that. And that, to my mind, being essentially a lot of what we're talking about here is like, you've got all your classic security stuff. Don't get hacked. And like don't use password 1234. You always have that stuff. That's good. But a lot of what's going on here is if that you're doing like weekly or daily deploys of software, there's a whole new set of concerns that you have, security concerns, especially if you're trying to get your developers to be the ones who have more responsibility over production. And then even down to technical things, like if you're using Docker images or container images for things, you've got to figure out what do they say, provenance? Yeah, you got to figure out where it's from and the approved ones. So there's a lot of seemingly really boring things like managing packages.
Yeah.
And I think a lot of it is also, I think the other side of it is there is a lot of process to make sure things are secure and compliant that traditionally has been done either manually or like pseudo automated, which is fine if you're operating at a traditional speed. But again, if you're trying to do things quickly and you got a lot of moving parts, it's just like, that's not cool.
In the federal space, you have these massive packages of things going across the classified environments in one big bang shot. Sometimes they're just wacky things like virus scanning things that they're binary it just doesn't make sense, right? They're using, McAfee virus scanning or something like that. So there are some outdated processes, but I think like what we've done at some of my federal customers is front load as much as you can so that by the time you show up to security, you're like, hey, here's this treasure trove of all the security related stuff that you could ever care about. Can I bring this over to the classified environment? And the thing I've seen is that the reasons to say no, just as we've automated more stuff with Tanzu, the reasons to say no keep shrinking to the point where conversations are taking, you have, I think one of my customers they had a full loop where a warfighter reported an issue with an application and they were able to push that application to production, which means going over to a classified environment. So starting in dev, ending up in prod in 2 hours and 45 minutes.
Oh, wow.
Like
really
unheard
fast.
of. In the
That's fast for anything.
Yes. Yeah.
It takes longer to make a prime rib than that. And then the other stuff, there's a couple federal specific things, US federal specific things about encryption and things like that, which are details of interestingness. So what we were talking about would be interesting to do is the other thing that was nice about the conversation and that we'll get into here is, as you're alluding to, there's actually like very specific things that you can do that satisfy are you secure? And you can say, yes, because we have these things. It's actual, like, it's not just culture, as it were. There's actually tools and things involved. So with that, show us what you got.
All right. So we'll start. We'll go through the main things we're going to be measuring for here is security, consistency, speed, and scale. Those are all important kind of facets of delivering software, right? So everything's going to start with, if you're doing user-centered design, everything's going to start with the designers going and talking to the users. In the federal case, a lot of times, in the DoD, these are warfighters, people who are actually serving in the military, trying to do a thing. I'm trying to interact with this satellite. I'm trying to look at this imagery and do something, right? And they're going to generate ideas, and the designers are going to sift through those ideas. And eventually, it's going to make its way to the developer. And hopefully it's been distilled down into backlog stories at this point with the product people. And okay, we're going to go build this thing. That's the first step. That needs to happen first. So we'll fast forward to you're building the thing. And so VMware has rallied around these two frameworks, Spring and Steel Toe, as a way to build cloud native applications in these two different languages. And so we have our first Tanzu piece of the puzzle, which is VMware Spring Runtime. So your developers are in their development environment. They're developing in the Fed space. There's a lot of VMs plus containers. Sometimes you're doing things so low level in the operating system that you actually need a VM to do it. You can't just have the container madness does not solve your problem, right? You actually need emulated hardware. There are situations with VMs. So your developers are in their development environment, they're doing their stuff. And with VMware Spring Runtime, they're covered with regular Java supports and updates.
Tell me if I'm wrong, but I think the important thing to start tracking as we look through this is selecting Spring or the other supported development things as you'll have to tell me what people call it nowadays, but your development framework or your middleware or whatever that is, like that immediately has good implications for security because there's a lot of things built into Spring that allow you to, do all the security things we're going to go over. It's beyond just like a normal programming language. There's actually hooks and levers and things you can go in to start doing all your security stuff, as we'll get into.
Yeah, it's truly a cloud native application. Spring and Steel Toe are truly cloud native application frameworks. The languages, sometimes I trip up and I call them languages. They're frameworks, right? It's the underlying language is Java for Spring and .NET for Steel Toe. But they're really honed in on this building a cloud native application problem. That's really what they're trying to solve. And so there's tons of boilerplate code there that does a thing like connect to a database in the most secure way. You could write that code yourself, but you may not want to. There may be someone probably did it better than you at some point.
And I think also to that point of a framework, one of the patterns we'll start seeing here is that the more variability you can reduce, the easier it is to secure things, which, as you were just saying, right? If there are 10 different ways of doing database integration, you now have at least 10 different things to worry about securing. Whereas if you have the conventions and the kind of, I always know this word is used incorrectly, but you standardize on the way everything is done. It makes your ability to go in and secure things a lot easier, which is another benefit of having a framework like Spring or Steel Toe or whatever.
Yeah, you'll definitely see that consistency thread. You'll see that throughout this whole Tanzu story, for sure.
All right, so we're set up here.
Right?
What happens next?
Your developers, they made the feature. They did the cool thing that the person asked for. They did it. And so now they're like, okay, we want to take this to production. So what's next? So the first thing I want to touch upon is you're going to go through some continuous integration process. That's what the CI bubble is. And you're going to run unit tests. You're going to do all the things you should be doing in test-driven development. And you're going to be testing that the code is good for release. Okay, great. At this point, it shows up to Tanzu Build Service. That's our next product. And the code is checkbox. It's good to go. So this is where we run into trouble with, there was actually a post on Hacker News about it a few weeks ago, and the comments were just amazing to read through. It was a pretty tame discussion for Hacker News, but the basis here is you have two main ways of building container images, right? So your app is going to be built into a container image. There's two main ways to do that: Docker files and what Tanzu Build Service uses, which is build packs, which is part of the Cloud Native Computing Foundation. They're the people that distribute Kubernetes. Cloud Native build packs are a incubating project with them. They're gaining a lot of traction. Pivotal and Heroku were big players in the build pack space. Google's now getting into it and tons of other companies, but this is that consistency thread. Docker files, they're really hard to manage at scale. I know some people they'll do nested Docker files where your Docker file builds a container image that another Docker file pulls from that builds a container. They'll do that nesting. And so for some folks that works, and certainly for the folks that were early adopters of containers, they've matured that process. But a lot of people are just getting into container technology. And so just using Docker files all over the place can really be hard to manage and scale. And it can also pull in unsafe dependencies. Basically, your developer can sit there and say, I want to pull this container from God knows where, GCR. I saw it on Stack Overflow. I want to use it. I read about one not too long ago that was basically, it was an Alpine Linux image that someone had put on Docker Hub. And when deployed, it was mining cryptocurrency for some nefarious person out there.
Of course.
Yes, of course. That's what nefarious people do.
Yeah, I think the history of letting developers do all their own infrastructure work is varied in success. And a lot of the point of DevOps is to try to get developers better at that and get the operations people to do things in a way that is more friendly for developers. But it's a challenge to have developers building all of their own stuff. And again, I think it introduces like a certain amount of variability. And what I always thought is interesting about build packs is it's, in theory, it offers developers one less thing to worry about, which is often a problem because developers like worrying about things or building things. But then also, like, to use an old developer term, there's a layer of abstraction, which you're supposed to love layers of abstraction, right? Because it allows for flexibility and all sorts of things like that. And build packs are pretty good at being like a descriptive recipe of what you desire, not exactly how to build it, which is the dream of layers of abstractions. There's the old developer thing of like, I don't want anyone to tell me how to do my work. I just want them to tell me what they need.
That's essentially what it is. Yeah, you hit the nail on the head. The developer is telling you what they need. Hey, I need these libraries. I'm going to need to, I don't know if they would care, but I'm going to need this underlying operating system. Go build my container. Right? We could adapt Anzi Fakori's haiku of here's my code, run it on the cloud for me. I don't care how. This is, Tanzu build service is very much here's my code, build a container for me. I don't care how, or build packs could be.
And then with your Fed people, they'd be like, no, there is no cloud. I don't think you understand. There's just this little hole that you put a USB drive through.
Exactly. You have no idea what's up. Yeah. So with Tanzu build service, you're getting the main thing here is you're getting regular common vulnerability and exposures, so CVE updates for both the libraries. So like in this image, I have the app at the top. This is like the layered cake image, and the OS at the bottom. So from an operating system perspective, with Tanzu build service, you're getting all the FIPS libraries, which is one of the things that federal people need, which basically says that any cryptographic communication that you're going to do, you're going to be using these cryptographic algorithms. They're approved and safe for federal usage, right? So those are all the FIPS libraries. That's something that's unique to Tanzu build service. Also, having the ability to build these containers offline and have the build packs run and include all the dependencies. So these blank images in between the app and the OS, these are like your libraries, essentially. There could be CVEs that come out for the operating system. There could be CVEs that come out for individual libraries. All of them are going to be patched by just using Tanzu build service can pull in the latest updates for both they're called stacks and build packs, but we don't need to go over that here. But the build packs really provide a way to standardize how your container is going to be built or what you need, what the developer needs you to go build.
And so what the combination of build packs and the build service is doing from a governance perspective essentially is it allows you to enforce using the code you want used and exclude the ones you don't want used. You as the governance person, the security person can specify, I want these frameworks used. So always use those frameworks. And hopefully it's not like annoying and limiting and stuff from like 1982 that is the only thing you have to use. Instead of developers being the ones who have to figure out and comply to the proper framework to use and download the right thing, again, through a build pack thing, they can just say, I need this this framework. And someone else should make sure I'm not doing something bad. And so you're removing from all those different developers teams and individual developers the need to worry about, is this framework patched? Is it approved? Does it have your FIPS compliance and all of that stuff? You can push that off onto someone else if you go through this process of doing stuff.
Imagine if a vulnerability did come out. So with Tanzu build service, if there was a OS level vulnerability or a vulnerability in one of the libraries, you would patch it in one spot and then every downstream container would be updated. That you patch once and you're done.
And that's the second part, exactly, is that when it comes to patching things, you don't have to go back to all the development teams. In the best scenario, you can just update the frameworks, and it's probably good to test things. At least you have a lot more productivity. It's a lot more efficient to upgrade everything than going and visiting all the different teams and figuring out what they're using and so forth.
Yeah, because with Docker files, it's essentially, you can almost imagine each team. So there's three containers here. Most likely, if these are different teams, they're going to be three different Docker files with three different ways of building the container image and three different base OS images. So if a CVE comes out and your chief security officer is like, have we patched this CVE? Your answer with Docker files could be, well, we told these 5 app teams to patch their stuff. We've heard back from one of them, or 2 of them have already patched it, but the 3 aren't, so that's really where build packs are a nice balance between, hey, our operators are going to enforce some consistency and some build process around how you're building your applications so that we can scale, but not locking the developer down so much that they can't get stuff done. And there are always nuances, right? But that nice middle ground.
And so to this point, you basically put up a model, a system of all the touch points that we'll need to run things in a secure way. And to also not run things so much, but like to make sure that we're building our features securely and we're complying with the security that we have. And so we've opened up all the little portals that are needed so we don't have just like black boxes and weird stuff. We're standardizing the way things are going and adding in the tools for rebuilding. So then what's next? And the magic whiteboard.
That container image is actually going to get pushed to a container repo. We use Harbor. A lot of VMware stuff integrates with Harbor. It's pretty much the leading container repo in the cloud native computing foundation space. Out of the box, it has integrations with things like Trivy and other vulnerability scanners. And it can also be a central point for enforcing, let's say a critical vulnerability makes its way into a container image in Harbor, or there's a critical vulnerability in an existing image and it's found out later. So the container image has already been built, it's already there, and voila, there's this critical vulnerability. You can enable in Harbor, you can basically say anything that has a high or critical vulnerability, don't let developers pull it down. Don't let them use it. No one, right. It's like a choke point, right? No one can use this.
It's like a remote control vending machine where when the milk expires, you can not sell that milk anymore. And then it still offers up all of the lovely beverages and snacks that you put through your secure build chain.
Is that a thing in Amsterdam? Are they that?
No.
I was going to say, because that's pretty advanced.
Because expired. That's right. You have to sign a release if you want to drink that milk.
So Harbor is a pretty simple one. It's open source. There's no, that you don't have to pay VMware a dime for it. It's not really, it's the place that we store our containers. The next big one is Tanzu Application Catalog. So what Tanzu Application Catalog does, and if people are familiar with Bitnami, so VMware acquired Bitnami, therefore acquiring tons and tons of automation, really sophisticated automation that updates container images and Helm charts for backing services. So for those who don't know what a Helm chart is, I'll start there. It's pretty much the blueprint for deploying things on Kubernetes. So it's really important that developers coming in don't bring their own Helm charts, or it can cause a lot of, again, we're back to the consistency discussion. It can cause a lot of churn if people are just coming in with, forget your blueprints, use my blueprints. That can imagine building a house. That would be...
that was the analogy I was going to use. It's like everyone knows that custom built house is an adventure.
Yeah. And switching blueprints halfway through probably isn't fun either. Yeah. So Tanzu Application Catalog, using this years and years of Bitnami automation, is automatically patching and updating these Helm charts and their associated containers. We'll go with MySQL, right? A backing service. So your app container is now in Harbor, but you need a database. No app can be just standalone without backing services to back it up. So in Tanzu Application Catalog, you're going to have this MySQL Helm chart, which is going to be your blueprint for deploying the most MySQL on Kubernetes in the most secure fashion, with all the knobs and tweaks made. You can obviously override those, right? Helm charts are highly customizable, but it's also going to come with the container image associated with that Helm chart. That's going to be the actual thing running on Kubernetes, the actual container of MySQL running on Kubernetes.
From the top, we have the custom written code, your in-house code. And then that goes through all the stuff we're talking about and gets into Harbor. And then from the bottom, the Tanzu application catalog, or as I'm sure us VMware people say, TAC, love to acronyms, but the Tanzu application catalog, I should say by brand rules, we're probably supposed to say VMware Tanzu application catalog the first time we mention it, and then we can drop the VMware. So
yes,
I've covered us here. But so that is more where there are, let's call them third-party frameworks and libraries. That's a whole other vending machine. So like you're saying, like a database or a queuing system or things you have listed here, but we'll go with database. That there are, I imagine there's multiple packagings of that in the Tanzu application catalog. And also what's in there, not only the container image, but you have, as you were saying, you have a Helm chart. And a Helm chart basically describes the configuration and what would you call it? The layout. It's the configuration for doing a release on Kubernetes, right? So if we have a Postgres database, here's an image that we have, or probably the images that we need. And given a Kubernetes cluster, here's how you deploy it on it. And here's how you configure it for whatever usage you are. And then as the last part you were saying, germane to doing DevSecOps in the Fed space, you can go in and modify those Helm charts for whatever you need. Right. So you could add in, I forget what we're calling it now, whether it's sidecars or load controllers, like the vocabulary changes every year. But you can go in and say, I want to load up this extra thing. I don't know if we say agent anymore, but I want to load in an agent with this. And the agent, or the whatever we call it, this additional chunk of code that's going to run and mediate and hang out and be like a guard to the database, that is deployed in our way of doing Postgres. And so again, less variability and more control and the ability to enforce what you want security-wise.
That's exactly right. And you're pulling, so back to your big word provenance earlier, you're pulling all this stuff from TAC. So your app code, you're going to have to write that. And there's no one's going to write your app code for you, but we certainly can control where your libraries and your OS images come from. That's where Tanzu Build Service comes in. As far as like open source projects, MySQL and tons of other Postgres, whatever, you can't control the code that the open source developers wrote, but you can control how you package it and maintain it. And you can have someone like VMware making sure that those are secure and patched. And that's essentially what Bitnami has been doing for the past 10 years or something like that.
Yeah.
Because the alternative is pulling things from the internet and the scary, spooky internet. That can be fine, but it can be really hard to support. And it can, again, back to the Alpine story with the cryptocurrency, nefarious cryptocurrency miner, that can be a big issue. And so TAC solves for that. And again, I had mentioned earlier, by the time you show up to security, you're shrinking the amount of reasons that they can say no. Every Helm chart is hardened with Bitnami best practices, and every container is hardened with Bitnami best practices. But on top of that, every release of the coupled Helm chart and the container has an antivirus scan that comes with it, has a vulnerability scan that comes with it, and has an asset list so that you can actually, your security folks can go through and see every single thing. There's nothing hiding in this container at that point.
Or just hiding by nature of, I don't know if it's obscurity here, but just like lack of paperwork.
Yeah.
You don't know what's in there, but there's a standard way of documenting the payload.
Yeah, it's a giant JSON file, and your security folks or whomever can go through and write some automation to, if they really hate this one or you really think this one vulnerability is a problem, they can go through and parse through all your asset files of things you're bringing down and look for that one thing and be like, I don't like that. I want that updated now. And so with TAC, you can have things pushed into your harbor directly. You can pull them down. So some federal customers, they'll pull things down from TAC over the internet, and then they'll run it over the line to an air-gapped environment or a disconnected environment and upload it there. And it's all using Docker pull push. There's nothing special. There's no special TAC CLI. There is a CLI for interacting with the API, but there's no sort of, you can't use Docker pull and push and stuff. You're using the stuff that your ops people are familiar with. So yeah, at this point, you got your image in Harbor, right? That's how most people use it. Your TAC, MySQL image in Harbor, you get your Java app in Harbor. You're ready to go through the next step, which is continuous deployment. So you'll use that Helm chart, you'll deploy the MySQL database, you'll deploy the app, everything. If you're watching your pods come up, everything's 0 out of 1, starting to do liveness probes, readiness probes come up. But here's the thing. So when you're deploying to Kubernetes, all of this stuff can work with any Kubernetes, right? Tanzu build service deploys on any Kubernetes. There's no specialness there, right? TAC is a SaaS thing, and Fed folks can use it because it's not, you're essentially trusting a source, right? It's not like you're storing nothing is going outbound.
Oh, right. Because you copy the stuff from it. You don't actually run it on the other side of that small tube wall.
Yeah, it's the same story behind like TanzuNet and authorizing officials trusting things from TanzuNet or PivNet, previously called. But so here I want to touch upon, this is where VMware TKG comes in for those who are wondering, I've heard of that TKG thing. What is that? That is VMware's, I guess you could say, distribution or flavor of Kubernetes. What I want to be careful with there is it's not like a fork of Kubernetes, right? We didn't take the Kubernetes code and say, all right, that's nice, open source developers. We're going to go and develop features that supersede what you've done. We move at the pace of the community. That's what all of these major EKS, AKS, GKE, all of these major folks are realizing that you got to stay aligned with the open source community. So we're doing that as well. But the main difference here is that TKG can be deployed on any Amazon EC2, Azure, Google Cloud, any of those things. And you can have it roll out the exact same way every time. And it's deployed consistently. So again, we're back to that consistent piece tied in with security. It's deployed secure out of the box. So using things like pod security profiles and other Kubernetes best practices, those are all done out of the box. And of course, you can modify it and have it rolled out your specific way that works for your operations team. It's regularly updated and patched. Like I said, open source aligned. So this is really the baseline. If you already have a Kubernetes distribution you're using and you love it, fine. Everything here works with that. But if you'd like that common Kubernetes dial tone, because maybe you're going to take that same Kubernetes deployment and automation and run it in an air-gapped environment where there is no AWS or there is no major cloud provider, or you're going to run it out in the desert somewhere, right, where there's no, don't think about this, but oftentimes the people fighting these wars, they're out in the middle of nowhere, or they're in tactical deployments, or they're somewhere that you wouldn't normally think of, but they still need their apps, which means they need their platform if they're going to be using, certain platform stuff. So that's that base layer. And we'll move on to what is the next piece, which is automate everything. Right. So this is a broad statement, but the idea is that everything else that we've mentioned so far is meant to free this is the new ops programming, right? So there you have application developers, and through GitOps, through things like this, if you partner with Tanzu Labs, there's this new idea of operators are really becoming quasi-programmers, right? It's not as much point and click. And eventually things will get there where we're building GUIs on top of things, especially with VMware. We built GUIs on top of everything. Pivotal built GUIs on top of Bosch manifest. So eventually there will be GUIs for a lot of this stuff, but the GitOps workflow is really powerful and it's here to stay. So if you're already using GitOps, or you already have a sophisticated automation capability, you can continue working with rolling out TKG or rolling out these services. Again, that's why there's a line going from GitOps to continuous deployment. There's a lot of work that's going to be done by your operators to tweak those Helm charts coming from TAC to make sure certain flags are enabled.
Go over briefly, what is GitOps? What's the deal with that?
So GitOps, quite literally, and it's funny, I was actually writing a blog post to go along with the video we did previously, the DevSecOps video we did, just like an accompanying blog post. And I was going through that and I realized that I realized two things. There is no standard definition of GitOps, so I made my own. And the second thing is that the more I think about it, it's called DevSecOps because security is at the middle of everything. But really it's like DevOpsSec, or like ops is the heart of every, because the first thing, like in that blog post, I was detailing what you would need to do to roll out this capability. The first thing you do is you have to have that automation tool, right? You can't automate things with a thing doer. That's where Concourse comes in. So you start off by automating the deployment of the automation thing, right? So automating the deployment of Concourse. Then you have this control plane, right? So this is where I'll define GitOps. GitOps is using version control, so Git. We can pretend that other version controls exist, but we'll just say Git. That's why it's called GitOps. To do all of your operations through version control. So if you're changing, let's say you want to change the way trying to think of a very standard.
You can add like a subdomain into a machine, and then you could map a URL. You could modify your web server configuration to map a URL to something.
I would go with the web server because the first one that came to mind was like doing something with Active Directory or something like that.
Yeah, in this example, there's literally some plain text file somewhere that you're just changing some characters in.
Exactly.
Right? And in the not GitOps thing, you would SSH into that. This would be the terrible thing. You would SSH into the box, load it up in VI or Emacs or whatever, and then just modify it. And that's everyone's nightmare scenario.
You would just YOLO modify it and let's see what happens. Restart the service. Restart the service. Does it come up? Oh, crap, it didn't. Okay, let me change it back. So with GitOps, all of that is defined, and it can be, it's weird. That's why Tanzu Labs is so effective here, is because for folks who haven't been doing GitOps, it is a mindset change, right? You may have these traditional operators that are used to going into Active Directory, or they're used to going into these interfaces and configuring things. And there's all these certifications. Even VMware, we have our vSphere certifications, right, around working in these GUIs. Whereas with GitOps, you're doing everything through API, everything through automation. That is the way of the future. And the reason it's so powerful, like you said, changing that one line, if you've automated everything, right, it should be super easy for you to, you don't even have to change the thing in production or dev. It should be super easy to just spin up a sandbox, recreate the entire state from scratch, because that's what anyone who's been in the IT field for a long time knows, that like you run into this issue where, I don't know why it worked this time. You'll click through something and be like, it worked this time. I don't really know why. Chances are the state changed. And with GitOps, you're basically automating up to a certain state. You can get the system to a certain state consistently every time, which means that you can limit, it's a huge power troubleshooting tool, because you're able to provision everything from scratch, make the change. Did it have the intended effect? If it didn't, well, your state's the same. You have to go back and kind of reassess.
Yeah, it's a good, most, I don't know what percentage, I'm sure it's some high double-digit percentage of problems that happen with computers is like the configuration's wrong, right? Or to generalize it, it sounds absurd now that I'm about to say it out loud, but something changed, right? Or I think in a mechanical thing, like if I think about my bike, often when something goes wrong with my bike, it's because something broke, or like air escaped the tire, or like the chain is rusted, or like nothing changed about the bike. It just degraded, like it just wore out. Whereas like with software, things don't wear out. What happens more commonly is like something changed and it caused a problem. So that's often what you're hunting down, is what changed. And if you have, as you're saying, this goes back to the idea that the chef and the puppet people they played a big role in this, is that you should treat your infrastructure as code. And that implies that like you don't SSH in there and edit a file. Instead, you go through this process. And I think, tell me if this kind of jives with what you were writing, but the idea behind GitOps is the next step of that is that if we're treating our infrastructure as code, that means we should check in everything and version it. And then even more, as you're saying, we should do a build to build a server. Like we basically build a server. And then, yeah, it has all sorts of exciting implications you were just talking about, where we can almost bring up different versions of production to see what's going on.
You could version your whole production environment, right? Yeah, that's a great way to put that. And And to touch upon like the Ansible, Chef, and Puppet stuff, there's probably still a role for those things. There's so many nuances in this field. You can't categorically say, you don't need that anymore. I think with TAC, it's a little bit more cut and dry. A lot of that stuff has been automated for you. So you're just using GitOps to go and deploy them.
And what you've crafted here so far is based a lot more on images and built artifacts rather than pure configuration automation, and it mixes those two things together. And then another thing, just to layer on more gold plating, as I like to do, is especially in your as you say, air gapped or your narrow tube situations, it's almost like you can say, here's the version you should upgrade to, right? Like don't necessarily think about it as a golden image or even a build. Well, I guess it is a build, but here is, you can take these instructions and now you can build this all afresh on your own. Like you actually can pretty much duplicate what's going on here. Like it reminds me, I forget which Bruce Sterling story it is, but he had this idea of like, in the future, building will be cheap because all of the components will be broken down into parts. And there'll be so much like precision and GPS locating and the way people's are facing that you could get anyone and you put the little earpiece in and it's walk over here, pick up this thing, turn this direction, put it down here. And then so it's a lot easier to build things because no one needs to like think about how it all fits together. And so similarly, you can build up a version of production because people don't have to think about what they're doing. They can just...
That's a fascinating way to put that. It's funny. I'm now thinking about, that's what Google is, right? Because with software, it's like you just Google things and there's still a need for computer scientists, right? There's no, we haven't automated ourselves out of jobs yet, and I say yet for a reason. You're like Googling things and you're just looking up how to put them together and then assembling things a certain way, obviously with foundational knowledge. And that's where there's a very complex landscape nowadays. And Kubernetes is a disruptor on many levels. A lot of the way people are looking at using Kubernetes is, a lot of what we discussed today, I won't go into this. This is like advanced Kubernetes, but a lot of what we've discussed today is I'm deploying a thing on top of Kubernetes, right? But Kubernetes is a platform, is a thing that you can use to build platforms, which means that you can now, and this is where the turtles, I actually love, there's one project called Cluster API, and its logo is a bunch of turtles in reference to the turtles all the way down. A bunch of turtles stacked on top.
Sure.
But that's what you can do with Kubernetes. You can have Kubernetes managing Kubernetes that manage Kubernetes that do a thing. And so in this GitOps flow, you now have a few things. You have you're tweaking the configuration of your continuous deployment. You're, in some cases, tweaking things in that continuous deployment that's deploying services on Kubernetes, right? Like, for example, there's something called KApp. It's part of the Carvel tool suite. If people are interested in Kubernetes, totally check it out. And KApp can be deployed as a controller and it can do whatever you want it to do. It could monitor other instances of KApp. It can be configured to monitor GitHub, right? So in many ways, and this is what we're doing with some stuff internally in R&D, is we're actually building Concourse, but Kubernetes native Concourse, or we're building an automation engine that's using Argo CD and some other component Kubernetes native functions to actually just build the thing in Kubernetes. So you're getting to the point where you can just build whole capabilities in Kubernetes. That's what I want to remind people about, is we talk a lot about building on top of Kubernetes, but Kubernetes itself it's almost like the language for operators, right? You have primitives, just like you have var, int, whatever in programming. A string in Kubernetes, you have pods. You have.
I think you're incredibly accurate, right? Like I always play around with the idea of saying that it's an enterprise architecture, right? Like I think a lot of what people miss out about Kubernetes is that, with the asterisk of there are always exceptions, so forth and so on, but basically, there is a very limited set of ways you can design and even run your software that runs in Kubernetes, right? If you're doing a distributed application, It's very constrained in what you can actually do. Like you can't just do whatever. And as you're saying, because of those constraints, it forces you into a very specific architecture for your application and a very specific way of configuring it and so forth and so on. And so exactly what that means is that you can craft that enterprise architecture to fit what you need, paradoxically from what I just said of it being constraining. But it allows you as an operator or someone running that to say, this is our enterprise architecture. So this is hence the platform that we have. It's not just the operating system. Like arguably, you could call Linux a platform, right? If you like hard code to the way Linux is doing and you're shelling out and calling awk and pipes and all this kind of stuff, which I guess is the intention of it, of Unix and everything. But we've moved away from that. The platform has been raised up from the operating system into, I don't know.
In a sense, this whole drawing is the platform, right? It's
right.
You know, if you think about so platform as a service, if you think about what Google App Engine or Tanzu Application Service, previously Pivotal Application Service, PCF, if you think about what all that was doing, code goes in one end, comes out on the other end, and it's running, and users are happy. That's what this, if you look at this drawing, that's literally what it is. It's just that's why Tanzu Application Service continues to have tons of customers and tons of happy customers because it does that really well. But what you've done is you've unpacked, like, I think about what Tanzu Build Service does. That's pretty much Taz has a function that does that turns code into.
And to the GitOps part and back to thinking about making something very secure and what's the determinate, right? Like determinism is great because then what's going to happen, especially good for people who care about security. And aside from the SaaS part, which you could wangle around, like similarly, this whole thing on the board, more or less, you could check in. Right? Like it's all
modular. It's all
right. You can build up from scratch rather quickly and sort through things. And there's entropy in every like software thing eventually. And you're just like, I don't know what to do with this because it's 30 years old. But in theory, if you're going through this hygienically, you're slow down the entropy of technical debt and not knowing what things are because all of it is transparent and standardized, a lot more than not. And so it brings you that security goal of I know what I have and I have a track record of it all the way from the frameworks that I use over on the left side. And then even to how we compile and build production. So we've got all like controls. That's another thing is like, automation is, I think we often think about it as speed and productivity and removing boring, tedious work. But automation is also control. It allows you to control things that previously were not controllable.
And it's just where things are headed, right? It's where a lot of ops jobs are going to turn into this. Right? This is the future of ops, right? You're looking at it where, like I said before, an app developer logs into their computer every day and they go write some code. Operators are going to log into their computer every day and they're going to, start tinkering with pipelines and automation and writing scripts that do purpose-built tasks and all sorts of things you're going to build on top of your automation tool, which is why I said like ops is really the glue between the dev and the sec, right?
Yeah, sure.
It's the basis. So to reset here, the point of this automate everything block is that everything Tanzu does is meant to free up your operators so that they can do automate everything. Like they could do GitOps. They can log into their computer every day. They're not going over and check if there's a CVE coming out. They're pulling down the latest build packs and stacks from TanzuNet, updating them and seeing if the thing's patched everywhere. They're not, your operators aren't going out and now tracking down every app team and saying, did you patch your update? So I mean, you don't want operators doing those things. You want them to be in this automate everything bubble as much as possible. So then the next part, so we've talked about automate everything. This is part of automate everything, but it's a piece that's important, which is observability. So a lot of teams this is one of the reasons like Wavefront is really important or really popular, is a lot of teams need that level of observability. We talked about troubleshooting earlier. A lot of teams need that level of observability into their applications, into their Kubernetes clusters to be able to troubleshoot things. You can check out, anyone watching this can check out TKG extensions. It's part of the whole TKG umbrella. You can get support with it through Tanzu Basic. I think they have tons of plans for this going forward. But TKG extensions provides these out-of-the-box dashboards configured for Prometheus and Grafana. Just to peel back for the folks that don't know, Prometheus is how you're going to gather your metrics from your various components that are deployed on Kubernetes. Grafana is that dashboard that shows you all the visual metrics, right? FluentBit is your log exporter. So I'm going to go and I'm going to export logs from everything. And then you need some sort of log aggregator, which could be Log Insight from VMware. It could be Splunk. It could be whatever you want. But Tanzu Labs also plays a big role here where, okay, you need an observability feature. They've been trained to work with TKG extensions and configure these things to get very specific outcomes. I manage a platform and I want to monitor these key metrics. So there's the out of the box TKG extension stuff, but there's also crafting these custom dashboards, right? And honing in on, okay, how many pods do I have running? How many resources am I consuming? Can I cut down my AWS bill? All of these things that your operators care about because their product managers care about them. Because operators alone, they just run out of resources. They'd run up the AWS bill forever. You need these critical metrics to be able to troubleshoot and measure and be able to improve your platform. So that's a critical piece of it.
And then connecting to some of the philosophy we were going over earlier, like another thing that is connected to observability, but more general, like your production ops people, they are given a better tool to figure out what caused production to go bad. And we explicitly said it, but to make the callback, right? If you're versioning everything and you have for the version of production running right now, I can check it out. And I can not only check it out, but I can diff it versus the previous one. So I can find out exactly what the differences were. And again, chances are highly likely that whatever that differences are is what's causing your current problem. Not always the case, but it's a good place to start before you start dreaming up other places where things might have gone wrong.
That's absolutely right. The observability piece is that check. If your pager duty goes off and you have to go and fix a problem in operations, your first place that you may check is this observability feature that you've built into your platform, right? Those custom dashboards. You'll start going through and spelunking through logs and all sorts of things. But if all else fails, you always have that rollback. I'm just going to roll back to a known good state, which is possible because you've automated everything, right? And it can be less disruptive with Kubernetes and these declarative patterns where you're saying, I want Kubernetes to reach this state. And then Kubernetes goes and figures out how it's going to reach this state. It's very easy to roll back and roll forward and things like that. So that's the end-to-end. At this point, your app has been in running on Kubernetes since 2 steps ago when the continuous deployment thing happened. These last 2 pieces we talked about really are where you want to be spending your time as operators going forward to improve this is the feedback loop, right? That improves the platform. But at the end of it, you have these happy users all the way on the right, and they're using your product, and your developers are working on the next release.
So help me, just to wrap up briefly, help me list out the security aspects of this, right? How it does your security. And let's see, tell me what I miss out on. One of the things that anyone doing security wants to do is says, use this, don't use that. So use this framework or use this image or whatever it is. This thing you're doing, I want, it's bad to do this thing. I'm being very vague. I can't think of an example. Use this pagination framework for the pages of things versus this other one, which results in Bitcoin mining. So from the very beginning, by having that kind of layering of a framework, and then going through the way that the build service will build things for you, and then you can customize what the third-party packages are through the Tanzu application catalog, or what you put into Harbor, if you don't want to use that. You have that control of, I can at the front end, on the left side of a security person, I can limit the choices people have effectively. And so I can make it hard for them to choose the bad thing. Or to put it in the positive way, I make it easy for them to choose the right thing, is the positive way of putting it. And then I think also what you're able to do, because you have that layer of control, is you can constantly say all right, if the good pagination system now needs to be patched, I don't have to go all the way back to developers to do it. Or I can do that, but it's also, I just say, I've updated it. Now it's updated, right? Like you should go run through your tests as a developer. You don't have to like go do this on your own. And every single team you can do that for instead of having to do various different ones. And then I think the part that I'm always more theoretic than concrete is like, because of all the sort of ways of automating things and all of your GitOps stuff, I always feel like there's more of an option for security people to go in and do like audits, to really look at who built this, when was it built, as you're saying, what's the manifest of stuff that's in there? How could I do the paperwork to prove that everything's cool? Which my impression of a lot of security is that there's a bunch of emails and meetings and like Excel involved to do that work. Whereas here, you could automate a lot more of it, and it's a lot less onerous.
That's where again, all roads lead back to that automate everything thing, right? Where your security folks themselves could be writing things to interrogate the system, but also your security folks could be a user of the platform where you're saying, hey, I want all of the security stuff associated with this app to land here. So I have one place to check. And then your ops team can go make that happen. So it's, again, everything becomes a product team. Everything becomes, security itself becomes a user of the platform, or they just become part of some organizations, they embed security people on ops teams so that they can actually always be looking out for stuff like that. So there's that one you can get pretty creative with, but that's the general sentiment there. The support for offline environments is big, especially with Tanzu Build Service, FIPS libraries, all the stuff that in the Fed space becomes really complicated, or for some products is an afterthought with some vendors. A lot of it is taken care of here. So that's the main story, is like that consistency story is huge across Tanzu, which is big for multi-cloud. If that's where your organization is, a lot of organizations are going towards hybrid cloud, multi-cloud. Consistency is huge there, but also you got to update and patch things. And that's where VMware support and all these products, you look at every single one of these, they're all open source aligned, right? Spring is open source. The foundational components of Tanzu Build Service are open source. Harbor is open source. All the projects in TAC are open source. This is the future, because it's all open source, but then you have someone who's looking out for patching, updating, how do I deploy this consistently, all of the enterprise level concerns. And that's what Tanzu is really about.
Yeah. All right. This is great. It gives us a good end-to-end idea of what we talk about when we talk about DevSecOps, and cool. Especially in the area of software. If people wanted to, I don't know, follow up on you, see what's going on, what would you point them to?
I'm on Twitter, so at WillisC7. That's the main one. I try to keep up with it as much as possible. Other than that, yeah, if you have questions, like if anyone watching this has questions, feel free to message me on Twitter. I will answer you and can explain a lot of this, because I know in the Fed space, and there's more coming around Tanzu and Fed, but in the Fed space, there's a lot more information dissemination that we'll be working on and getting things out there so that the picture's clearer. And this is part of it, right? Giving you a picture of, in federal, this is the TLDR for this whole video. In federal, what Tanzu things can I use, right?
Essentially, there's a reference architecture ready to go, right? The pattern that you can follow. Great. Well, that's good. As always, this has been a Tanzu Talk episode. I don't know whether you consume it as a video or a podcast. There should be some related show notes, and I'll put in a link to the part 1 that Chris and I had, and other stuff if you want to follow up on that. And we'll see everyone next time. Bye-bye.